What's up, guys? This is Stan from Stanny G Tech, and today we're going to be looking at one more thing in Java, object-oriented programming, and we're going to be doing tutorial. But before I get into the actual tutorial, I want to say check out my channel. Make sure to like my videos and subscribe and click notification bell so that you see when new videos come out. And thank you guys for your support. Thank you guys for everyone who subscribed to me. So let's jump right in. Today we're going to be looking at basically a sorting and searching the array. First of all, before we start coding, actually, let's look at the physical array. So for this, I'll bring out Paint so that I could sketch the array and show you what it is. and So as we all know by now, the array is a collection that contains the information. In fact, you can see some arrays here. Can you spot some arrays in this exact program here? Exactly. Color array, right? Right here. You have color array. This is this is the array that contains colors. So probably when whoever designed this program within the Microsoft stored colors in the array. So this is exactly what the array is. But let me draw my own. So array basically is a collection of it's just a storage, right? With the different cells to store the information. So let's draw some cells here. So let's get so let's find the middle exactly here, somewhere here. I'm sorry for not perfect drawing. It's not my intention to draw perfectly. I mean, it's gonna, like, I don't know. But you get an idea what the array is, right? So basically, this is the array that's gonna store something, or objects, right? Whatever the object is, or data types, some data. So let me finish this up here. So this is our array. So this is, wait, let's do a little undo here. There. So we can see that we could store things. It's like a bookshelf, right? Or like a storage thing. So let's say we store something in those cells. Let's say we store integers. So let me go ahead and or numbers. Let's say we store quantities of workers in each office in the tall office building, right? So we store that as a data set, right? So let's see. Where's the text here? Text. Select new. I haven't used Paint in a while, so I don't know where Paint. I don't know where text is. All right. Well, I'll draw some numbers. So let's say we have 20. Well, no, it's not gonna work. Oh, text. Duh. It's right here. Okay, so let's insert this right here. Let's make it bigger so you guys could see what I'm doing here. All right. Something like this should be fine. All right, now let's also do the formatting so you could see what I'm typing, right? 26 would be enough. Yes, and we can actually put this down a little, can we? Yeah, there. Perfect. Okay, so let's say we have tall office building, and we store in this array, we store the quantity of people working at the offices, right, in this tall office building. So let's say we have one office with 23 people. We have another, we have another office with 14 people. We have another office with let's 33 people, workers, right? We have another office who's 22 people. We have 10. Then we have, I don't know, 40. Then we have 41. Then we have 32. Then we have 50. Then we have 12. Then we have 11. Then we have 10. And then we have, let's say 5, right? No, let's say 3, right? Okay, so we have this storage in our system. So this is Office 1, Office 2, Office 3, whatever. So if you remember, if you ever talked about arrays in the programming classes, the arrays always start counting at index 0. So the first cell would be 0, right? So let me go ahead and do this little thing again here. And let's say make this smaller. Let's say I make this 20. That would be fine. And I'll pick the color green for the text. I guess it's gonna change the colors. Hold on, let me just try. So if I put 0 here, 0, yes, 0, 1. Oopsie. I got a tab. What? It's not tabbing. Okay, whatever. So 0, 1. Where are you at? Where'd you go? 1. Something is not. Well, you get the point. It starts with 0, 1, 2, 3, 4, 5, 6, 7. If I can only type, but it's for some reason it's not typing, so whatever. You get the point. Start 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 11. So we have 12 indexes, right? And we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is not good. I'm just kidding. It's fine. So we have 13. Let's make it 14. So let's do another cell. I don't know. It's nothing, but it's just like so. Give me black. So 13 would be, let's say this one would have 0 workers. No, just kidding. This one would have 15 workers, right? So we have a 14 cell array, and let's say we have to perform some search and find an office that stores whatever amount of people, right? Let's say we're looking for the office that stores 12 people in there, right? We're looking for the office that has 12 people in there. So there are a couple of search techniques that we could do in here. One of them, which we've covered, was a sequential search, right? Sequential search involves looking, so element by element. So it goes through from left to right. In this array, it goes through from left to right, and it tries to find the value that we are looking for. So let's say the set value would be an office with 12 people in there. So when we use sequential search, what's going to happen? So it's going to go through the element 0, then go through element 1 and compare. So the set would be 12 people, right? So that's the target, right? We need to find the cell that has number 12 in there. So representing 12 people. So basically, hold on. So basically what we have to do is loop through this entire array for number 12. So we go through and say 23, no, it's not 12. 14, no, it's not 12. 30, 33, no, it's not 12. 22, no, it's not. It's so forth until it finds 12. Right here. Until it finds 12. And it says 12. Yes, it's 12. Ooh, boom, I found it. So it's going to look through, right? It's going to look through and compare the values, right? So it's going to compare, is 23 equal to 12? No. Is 14 equal to 12? No. 33 equals to 12? No. And so forth until it reaches 12. Is 12 equals to 12? Then it finds it. Of course, the sequential search is probably the slowest one. 1 second. Okay, so it's probably the slowest one because it goes through each entire thing. And what if it's an array with 100 cells or 200 cells or 1,000 cells, right? So to make it faster, there's another type of search that we could use. It's called binary search. Now, what does binary search do? Basically, it does exactly this. So it takes an array. Let me get the red marker here. It takes an array. It says, all right, so first of all, we need to find the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 7. So the middle, if it hits this, right? So in our case, if we put it between 40 and 41, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So actually, if we put it exactly at 41, so let the middle be 41. Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. No, the middle is going to be next to, actually, it's going to be this. This is going to be in middle here. So should we have an array, when it hits this, it goes a +1 this way, for example. So if it hits the middle of the array, we'll move it 1, right here. So it breaks it in here. But if it's an even array, if we add another cell, let's make it 14 cell array in our case, right? So let's do a 14th cell right here. So let's just add it, hopefully. Yeah, perfect. All right. Is it perfect? Now it's perfect. Okay. So let's add this cell with the quantity of 1. Let's give it 7 people. So let's give this one 7 people. So now then, the middle is going to be, so 1, 2, 3, so it's going to be 15, right? So divide 1, 2, 3, 4, 5, 6, 7. And if we set 41, then it's going to be 1, 2, 3, 4, 5, 6, 7. Yeah. So now, with this amount, with this array, so of course 0 is going to move. 0 is going to move here, so we're going to erase this, right? So let's erase this 1 and erase this 0, right? So the 0, the first element in the array, is going to be right here. So now this is going to be 0. Okay. So so in this case, this 41 is going to be our middle now, right? So the binary search first finds the middle, which is 41. Then it splits the array in 2. Even if it's, okay, so 41 is the middle value. So it compares the middle. If the middle is in fact the number, then, it says, okay, I found the number. It's right in the middle. If not, what it does, it breaks the array into 2 halves. So this one is going to be called left or first, right? This is going to be called right or last, right? So this is left, this is right, this is going to be called the middle, right? So now If middle is not the number, it's going to go and search here. And do the same thing here. It's going to break it in the middle. So 1, 2, 3, 1, 2, 3. So it's going to say, is 11 the number? So it's going to say, no, 11 is not the number. So it's going to keep on searching until it actually finds the number. So it breaks it, right? It breaks it here and breaks it here. And it keeps on searching. So this is basically how the array is searched. Now, here's another trick. To make it easier for the computer, right, to find a number, you need to do an array sorting. What that does, that puts the numbers in the array in order. So you can do bubble sort. There are a couple sorts you can use, right, to sort an array so that the numbers would be easier to go through and find, or the values, not necessarily numbers. It could be a value of some sort, right? So it could be easier for it to work with, right? So now that we know what the array is and what the search involves and sorting and searching and all that stuff, right? So we can go straight to the assignment, right? Actually, so let's just not save that. So to go to the assignment, we go here and we go to the assignment. I believe it's assignment 4 or assignment whatever it is. Assignment 3. Yeah, this is the assignment that we have to do. It says write an application that has an array of at least 20 integers. It should call a method that uses the sequential search algorithm. Create a class of with the file name sequential search benchmarker.java to locate one of the values. The method should keep account of the number of comparison it makes until it finds the value. Then the program should call another method that uses the binary search algorithm. Create a class with the file name binary search benchmarker.java to locate the same value. It should also keep account of a number of comparisons it makes. Display these values on the screen. The application should allow user to do the multiple search. So use the following numbers. So we were given the numbers. We were given an array of numbers here. And this is how the output should look like. You can go through actually, you can go through actually this code and see how it should run. So basically, let's go ahead and get started. So first we'll create our classes. So first thing, of course, we're gonna do, I have a classes already pre-made here, but I want to explain as I retype them. I want to explain what am I actually doing here. So let's do first a sequential search class. So this is a sequential. It's pretty little. There's nothing to really handle here. So pretty much what we're doing here is so let's go ahead and open our NetBeans. And let's create our program here. So here, application, and what should it be called? It should be called a, wait, where is it? It should be called write an application that uses array. It should method create a class sequential search benchmarker.java. Alright, so the application should allow, is there a specific name? Then the program should go, well, we can call it sequential search. I mean, we could call this one whatever. It's just we can create a class within that. So we can call it a search benchmarker, right? So we can call search benchmarker application, right? So let's go ahead and I'll minimize this. So let's call it search bench marker. So search bench marker. I'm going to create the main class, blah blah blah, you know that, right? So we have to remove this because we're creating a class. So now the first thing that we have to do is usually in classes we have to do some declaration, but here is a catch here. We can do it all in one shot. We can do a constructor and set the values and everything just doing one method here. We don't have to do, we can leave everything default. The system will know that this is the array, that this is, you know, such and such, conditions and constructors and everything, right? So what we do here, we created a class. Well, actually, no. Actually, we have to create a sequential search bench marker. Actual program has to be sequential search benchmark to create a class, right? Or we can do the main. Hold on. We can do the main program, but then it's going to be the same. Oh, okay, let's just redo this then. Okay, real quick. So let's just do sequential search bench marker here. Or actually, here, I have a better idea. Search bench marker. Here, I have a better idea. How about we'll do this? We'll leave this as it is. Search bench marker. Send me a class. Right? I'm going to add a file as a Java class and call it sequential search. It doesn't really matter, but for they're just like, you know, if you call this program sequential search, it's gonna mean that it only does sequential search. I mean, it will still work no matter what, but it's just a naming convention, you know. So you want to call this one a search bench marker, right? Sequential search bench marker .java. So and then add it. So it's gonna create us a class here. So then what we have to do is pretty much we have to do this. We pretty much have to say this is going to be a static method, so that means the method will change eventually. Static. I think static is the one that is. If you have a static, no, static is not changing. I'm sorry, dynamic is changing. Static is not changing. So static is a steady method that works, and no one can change it. So we can do public static method. So we do here a public static. So this is going to be an array, and this is going to be int array. Array. Set array. Thank you. All right, and we're gonna call this one SQL search. So I'm gonna call this one. So pretty much the default is gonna do all the declaration of this array and the fields and everything. So it's gonna do everything for us, so we don't have to worry about declaring the array and then writing the constructor. It's gonna do everything here. So sequential search, and it will have the following fields. It's gonna have int array of integers and int array of key. Int just key. So we're gonna pass it, and int integers. So I mean, we could of course create an integers array, and then default constructor, and then we're gonna put it in here. But for the sake of saving the code, I mean, it's just gonna happen automatically. So integers. So we're passing our array, right? We're passing the argument, and we're passing our array as an argument, and we're gonna also pass int key. Now the key, I named it the key, could be the value, could be target, whatever you want to call it. That's gonna pass in the number that we pass in, that the program passes in. So let's say we ask to find 96, or whatever, 69, whatever you want to search for, right? That is going to be stored in this in this variable here, the key, right? So then we need to declare a couple more variables inside the method, which is going to be index and count, right? So int index, and right away we set it equal to -1, because what that will do, that will pretty much sort the array for us, make it easier to search through, right? So this is how you sort, one of the methods how you sort the array. And then int, what was it? I want to keep it consistent because we're gonna just int count. A count is gonna count. It's gonna pretty much count how many times, how many comparisons it made, right? So then what we want to think about, this is a sequential search, so it goes through, hold on, no, actually SQL search, yeah, right here. Okay, so it's fine. So it goes through each element of the array, right, and tries to find it. So this is basically what I'm doing here. I'm saying for, and so I'm pretty much saying this. I'm given a for loop, for int I equal to 0, I is less than our array.length, right? Integers dot length I plus plus. Okay, then we're gonna think logically. What should happen? So we go through each element in the array. So we say if our index, if our array at index I, right, equals to our key, right? If it equals to our key, so if it found it, right? So it starts with element 0, right? So it's asking if 0 is the number that we are asking to search for, or we were asked to search for, then you found the number. So you just give it out, right? So the way we do this in this one, we just return the index, right? So return the index, and before that, of course, you want to do a count plus plus. Count plus plus, because you want to start the loop. So the loop starts and goes, okay, so now count is 1. All right, did it found it at 1? All right, so did it found it at found it at 2 on the second try, on the third try, on the it keeps on keeps counting the tries it goes through, iterations, right? Iteration. So if it is, if it found the value, right? So we just say, okay, we just say here index equals that value. Right. So here we found the so we printing out the index where it found it at, right? So we don't have to say, okay, the value is 69. We have to say, I found it, so it at that index, right? So and we break out of the loop. Breaks out the loop, right? So if this condition is true, it's gonna break out the loop and the program is gonna quit, right? And in this case, we're gonna have to return the index and the count. Now, if we think about how can we return two values at once? Well, we can do this through the array, right? So pretty much what I've done here is I created the array called return value, and it's gonna store integers, right? Integers array return. Okay, return value and return value, and we're gonna set it equal to the values of index and count. All right. So now when we have this set, we can simply return it. Return return value. So pretty much what we've done here, a little trick here. So we created an integer array to hold our return value, and we basically said, okay, this array is going to contain the index and a count. So we store index and a count in this little array with two elements, and then we return it. So it's going to basically give us the information inside the program when we call this method. It's going to give us this little, it's going to say, I found it in this index and then this count. So that completes our method for sequential search. Now we were also asked to do a binary search. So let's do our binary search. So let's save this. So we create a new file, right? We create a new file, Java class, and it's going to be binary search. All right. Make sure I type it correctly. Binary search, is it the same thing as here? Hold on. Let me go quickly to my desktop. And binary search, yes. So let me open that. Binary search. Okay. So finish. So again, it's going to create us the binary search. And you can go through again, create an array and creating the constructor, but you can leave everything default. It's going to create for you the default constructor, and it's going to declare to save time. And this is the method here that we're going to do. So pretty much doing the static method again, and pretty much we are doing the same thing, but this time we're basically passing more arguments here because we would need that. Because as you remember, the binary search first breaks the array in half, then it goes to the left side, to the right side, in the middle, and then it searches the, let's say, left side first, or whatever, the right side first, and then it finds it. It says, okay, it's here. If it doesn't find it, it keeps on searching, right? So maybe I'm wrong. Maybe the sequential is more faster than this one, the binary. But first thing we have to do is, of course, give it a count and the index, and we're going to sort in array. So first we think, again, we're sorting in array, int, index. Oh, wait, method. We forgot to write a method for this, right? So we forgot to write a method. So public static int binary search. So we're gonna do again the public static array of integers. It's called binary search. Now we're gonna pass it this. We're gonna pass it int or array of integers, right? We're gonna pass it a couple more things here. First, int last in key. So we pass it in first, int last, int key. All right. So now you're probably gonna ask, what about int middle? Should we declare the int middle? Yes, we should. What's not right here? Aha. Okay. So, what about in middle, you might ask? Well, first of all, let's sort it, right? Index, integer, index equals -1, and integer count equals to 0. All right, so now you can ask yourself, what about the middle? Well, think about it. How can we calculate the middle? How we can do this? How we can find the middle, right? So we need to do the pointer at the left, the edge at the left, right? And then the edge of the right, right? So first element, last element, we need to sum them to count how many of them in total, right? And then divide this whole thing by 2, right? So that's how we find the middle of the array. So that's exactly, I believe, that I've done here. So again, we have to write a while loop this time, because we have to say while first is less or equal to last, less than or equal to last, right? So yeah. So wow, first less than or equal to last. So basically what we're saying here, need to type right. Okay, so basically what we're saying, why first element in the array is less than or equal to last. So we're still looking for the element, right? So while the condition is true, the first one is less than or equal to last. Then we're gonna run through, right? We're gonna run through here, and we're gonna say int middle. Oh well, count plus plus. Of course, you don't want to forget our count. So it has to search. I mean, it has to increment. So we have our int middle, exactly as I said here. In mid, let's say mid or middle, doesn't really matter. Is going to be equal into, as I said, we're going to add first and last. So first plus last and we're gonna divide this thing by 2, and this is gonna find us the middle, right? Let me check that. Yes. Now we're gonna check the integers, right? We're gonna check our we're gonna say if middle equals to the key, then I found it. If not, then go through and find divide it, whatever. Just search the array, right side of the array, left side of the array, try to find it there, right? So that's the way we say that. We do the if statements. So we do if the value at the middle is less than key, so now that we do the sorted array, right? We we make sure that the array is sorted, right? So we say if the value in the middle is less than the value where we put in, then it's gonna go to the right, right? If it's greater than, then it's gonna go to the left, right? So pretty much that's what we're saying here. If it's less than key, then what we're gonna do, we're gonna set first equals middle plus 1. So pretty much what we're doing is, if you picture an array, we break it in the middle, and we say if the middle is less than key, so it's gonna go to it's gonna move the pointer, the marker, to the right? So we say middle plus 1. So then we're gonna start our first, right? First element is going to be not at the beginning of the array at this time, right? But it's going to be at the after the middle. Is going to do first element is going to be middle plus 1. Makes sense, right? So basically, if you remember the picture of the array, we're pretty much saying if the middle is not it, and it's less than the key, it's less than the key. So let's say we going through the array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the middle is going to be number between 5 and 6, or let's say 11. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the middle is going to be 6, right? In this case, the middle is going to be 6. So it's going to say if if the middle, and let's say we're searching for the number, let's say 8, right? So since 6 is in the middle, the 8 is to the right? 7, 8. So if it's gonna say the 6 is less than the key, if the middle, the 6 is less than 8, and it's true, if it's less than 8, then start from 7. Then move it 1 to the right? So that's what we direct in this. First, we're going to set the first marker. We're going to shift it to the right? So that's pretty much what we do here, right? So then we're going to say, if integers, if the, I skipped that, I'm sorry. So pretty much if in our array integers at middle, if integers at middle, right, less than key, that's the right way to say that, right? Then the first is going to be middle plus 1. Else if the integers of the middle is greater than key, right? Logically, right? Else if the integers, the middle on integers is greater than a key, So let's say we still search for um, 7, right? And the integers, no, let's say we search for 2, right? We search for 2. So if it's greater than the key, so integers, middle was what? Middle was 6, I remember, right? And we are searching for 2. Of course, it's greater. 6 is greater than 2. 6 is greater than 2. Then we're gonna say, okay, then we're not setting the first one because the first one is going to be beginning of the array. It doesn't make sense. We set the last now. So we're gonna move from last. So since we're moving from right to left now, we're gonna go that way to search to the left side. So this, the first way we search to the right. Now we go to the left. So how do we do this? So we say then the last is going to be equal in middle minus 1. Makes sense, right? So we direct it to the left, right? So now we do another else if, because we still have one more. Else if the middle is the answer, right? Else if the middle integers in the middle missed it. Is it doing this to me? In the middle equals to key, right? If it equals to key, then index equals the middle. Then we found it, right? Then index equals the middle. And then we're gonna break out. All right. So pretty much, let me go through this again. So this method. So it's pretty much the logic, okay? So we set middle equals first plus last divided by 2. So it makes sense that we divided the whole array in the middle. So we say, okay, so first element plus last. So whatever, just we drew the marker and then say, split it in half. All right, so we split it in half now. Now we go to the right. We search the right side. We say, if the middle is less than key, then we should go to the right. So we set the first cell to search from to the right, one right. So middle plus 1, right? We move it, shift it right, one cell. Else if it's a greater than key, we shift it to the left. Well, we go from right to left now. So from the middle, we need to set the last thing. It's not the first, because first is at the very left, right? Very left. So we set the left one. We say, okay, so last, and go from right to left this time, right? But else if it's right in the middle, then we found it. Then boom, we just said, this equal to the index, and then it found it. And then we do the same thing here. We return, right? So we return. We have to return the index and the count, right? So how do we do this? Exactly the same thing as we did the previous. So we can't do return. See, we can't do 2 returns. We can't do 2 returns. So we have to do 1 return. So how do we do 1 return? We return the array. Okay, so we say int return value. Of course, it's going to be the array. Return value is going to be equal. We're going to store in this array. We're going to store index and count, and then we're going to return it, right? That way it works. Are we going to return with the variable that stores our index and value. All right. So now that we have two of our methods completed in this one, so we have a method now. Now we jump into the main program. So we, of course, we save our work here. And we jump into the main program. So the main program is going to be where? Right here, I think. Yes. So now, what do we need in the main program here? Well, first of all, we need to import the scanner, or I just import the whole utilities thing, right? So import java .util .star to import all of them at once. Okay. So we import all of them at once. So that return that does the arrays, the everything, right? All right. So now we go to the main program. So now let me open up the main program here real quick. So I follow along as I do it and explain. So search benchmark. So this is our main program, right? So first we need to declare a couple of variables, and as we saw in the program descriptions, it needs to promote the user to run this program again and again, right? So where does it say that? Hold on. It should also keep count. Yeah, right here. Do you want to search again, yes or no? Or we could do yes or no. That could be Boolean. Or we can do 1 and 2, just they enter 1 or 2, right? So, yeah, 1 for yes, 2 for no, right? So let's do this. So for this, let's copy this. So we don't have to type it up, right? Well, this is going to be an array, right? So, so we declare, what was that called? Int user to continue. And I'm going to write annotations after I complete this. Int. So what we can do, I can actually right away declaring fields attributes. Why I say fields attributes? Well, some people call them fields, some people call them attributes. It's the same thing, right? So I need int. What's it called? User to continue val. It could be called anything. It could be just called continue if you want to. Doesn't really matter. So user to continue val equals to 1. So 1 is continue. Everything else is stop, right? So then we declare our array there. Then we also need now those are two values that we need. Then we need to again sort our arrays. Sort. So pretty much this array should be sorted, right? So arrays dot sort. This is the method that lies in the array library here. Hold on 1 second, just making sure. Numbers, right? Just making sure. All right. So now what we do, You think about it. So I want the program to continue running while user is pressing 1. So pretty much what we're gonna do is we're gonna run the program within the loop itself. So we're pretty much looping through the entire program, entire main program, until the user says, "Okay, I don't want to close the program." So we pretty much say here, loop through the program as long as the user wants to run it. Right? The way we say it, while what? I always set the wrong parentheses here. Okay, while this whole thing, the user to continue val equals to 1. Then this whole thing. Okay, so while this is true, while this condition is true, while it's equals to 1, it's gonna run through the loop, right? So what's gonna be in the loop actually? So we're gonna take the value from the user. First thing, we're gonna take the value from the user, right? So how do we do that? We use our scanner object. Keyboard equals new scanner, and it's going to be working towards the input system.in, right? So now we have to run this. Right? So we ask the user for a number. So system dot out. Hold on, make sure. I'm missing one parenthesis. Always check your curly brackets, because sometimes if you miss one, it's going to be a hassle. So, wait, incorrect one. Yeah, there. No. Yeah, there. Okay. System.out.print line. What's going to be the print line in there? Enter value to search for. Just being lazy. Copy paste. Boom. Alright, so after this, we're going to take the value from the user. And how do we do this? We store it in a variable, right? And the variable in this case will be, it will be value. Let's do int value. Could be anything, but equals to keyboard dot next int. Come on. There. Thank you. Alright, so now that we took the value, we're going to run the search, right? So we're going to also do another system dot out dot print in println rather. We're gonna type in this. You don't have to, but so that the user knows what the program is doing, which search is it using, right? So we're gonna do this exactly here. System dot out dot print all in, and we're gonna do that, and we're gonna call a method now. So we're gonna call our method, which is first one was called the sequential search. So now, since the result is going to come, remember we declared an array, so we return the array as a result. Remember, the return value is going to be an array of index and, so it's going to be index and count, and it's an array. Of course, we have to put it back in the array. So our int, I think int result array, right? Yeah. So int result, and this is going to be an array. I mean, you can do it this way, you can do it that way. You can, array is fine. If you put it in here, that's fine too. All right. So int result array, or if you want, I click on run. So int array result. Okay, so now we put it in here. We can put it in here, we can put it in there, it doesn't really matter. And now we're gonna call a method, right? So now we're gonna call a method. And we're gonna call this method, where is it? Sequential search benchmarker. And we're gonna call that, right? We're gonna call that method. Oh, before that, I completely forgot to do this. I completely forgot to do this to initiate our methods here. So hold on. Okay, so was it done here? I don't know why. Oh, okay. Yeah, we're just using this. Okay, so pretty much our array here is gonna store the sequential so it's gonna store it's gonna go with index and count. Alright, so we call this method, right? Is it index and count? No, sorry, values and number. It's from the constructor. I'm just making sure. Numbers and value. So it's going to return numbers and value. Okay. Yes. So pretty much what's going to do is going to go back to that sequential search. And it's going to go here. So numbers, which is index, and count, which is the value, right? So I'm gonna go back here. So we're gonna call this method, and now we're gonna print out the line, right? System dot out dot print ln, and we're gonna print this thing. But I'm just gonna copy it to make it faster. I'm just gonna copy it from here. So the value was found in here. Okay. So we print out the value was found in here. Oh, the value. Okay, the value is pretty much the number that we're looking for. The result, it's coming from here, right? The result is 0. So it's gonna print out the, whatever how many times it was comparing, and result at I is gonna print pretty much. Result at 0 is gonna print where it found, what index, right? And result at I is gonna print how many comparisons were made. And then we're gonna go through the same thing. We're gonna say, I'm just gonna copy this code. It's gonna be the same thing, right? So there's gonna be a system print using the binary search, and the result is gonna be equal to binary search benchmarker dot search, and we have to pass it. Since this was the constructor that had numbers, then it had the index, then it had the length of the array -1, so that's the last, and then the value. All right. So just gonna copy this, right? And then it's gonna do the same for the second method. It's gonna print out, do you want to continue? Yes or no. Yes equals 1, or no equals 0, right? And then at this point is gonna set the user to continue value. It's gonna set it to it's gonna take the value from the user, right? And according to what the value does it take, if it takes the 1, remember we set it to while user to continue equals to 1, it's gonna run through this again. If not, if it's 0, then it's gonna drop out and close the program. So this is what we're gonna do here. So let's paste this in. Oopsie. Let's paste this in. Okay. Something is messed up here about binary search benchmarker. Oh, we called it binary search, that's why. So we forgot the benchmarker. So we would fix this up. To binary search. Not a big deal. Oh, okay. We'll not save this. No, don't save. Alright, so we fix this one to binary search to make it work. Doesn't really matter. If we call that class binary search benchmarker, now it's this binary. What do we call it here? We have to match. We have to go back and match kind of to what this method was called. I can fix this in here. Binary search, and then it should work now. Yeah. So pretty much we do this. So then we're gonna, as I said, we're gonna go back and see if it's, where's that text file? Hold on, let me go back and open that text file for you. So hello binary search and search marks, and then yeah, we have to say do you want to continue, and then we say keyboard.close in here, so we close the scanner object and drop out. So in here we have to say keyboard.close. Close is a method, so within the scanner, so it knows exactly how to do it. It has to, okay. On here. But actually in here. And no. What? Hold on. Let me make sure. Ah. Actually the scanner. We move the scanner here. I move it out. Move it right here. Okay, here we go. Now it's working. So that's basically what it is, guys. And if we run it now, it should give us what we need. So enter the value for search for. Let's say we put the value, I don't know, 11. Using the sequential search, the 11 was found at the element -1. So it returns -1 because it didn't have 11. So if we type, for example, if we type, do you want to continue? We press 1, we want to continue. Then it says, let's find 101. 101 was found at element 0. And it did one comparison because it was the beginning of the array, probably the smallest number. And then it did 4 comparisons to find it using the... So sequential actually search is faster than... we can see that sequential search is faster than binary search. I mean, rather, yeah, sequential is faster than the binary. Let's just make sure. Let's just check one more thing. So let's find the value 147. Okay, so took equal amount both sequential and binary search, as we see there. Do you want to continue? Yeah, let's do one more. Sure. Let's do 447. 447. I took the same amount to find 447. Oh no, no, the binary took sometimes. So the binary sequential, it took 17, right? And the binary took 5 actually the binary is faster. So I mean, you can make your conclusions upon this, Let's find 199. So it took 5 attempts of sequential search and took 2 attempts. So as you can see, the binary search is actually faster than sequential search. sequential goes through every single element. Yeah, I think I said that the binary is faster, right? In the beginning, we saw that the binary is faster. It just chunks the array in chunks and it says, okay, if it's not on the left, it's on the right. If it's not on the right, it's on the left. If it's not neither, then it's in the middle. Then boom, it found the array. So, I mean, you can see out of this assignment how you can actually make your own conclusions on which search is faster to use, and you're going to implement that search in your actual program and use it on a daily basis. And it works. We can see it working. It took a little bit of challenge to make all this happening here, because you have to make sure that everything is consistent. You have to make sure that you name your classes correctly. In which sense, I didn't, but it doesn't really matter as long as it matches as long as I call the class and call the method. So because in here I said I said binary search benchmarker, and in here pretty much I'm just accessing the class because everything is private. See, I mean public. See, when you have a private, you have to go through creating an instance of the object, copy of the object, and use it. If everything is public, you can just access it and use it without having dealing with binary search benchmarker dot. Binary search benchmarker, call it some object name and create an instance of the object, because you're already using the object directly. So you just can go through and call that method directly, since this is a public method and public everything. You can just do it, and the program will run just fine. So it might seem confusing, but if you sit down, relax, and think logically what you want to do within the array. Like, okay, so you see the line, you draw the array if you want to. In coding, in programming, it's always good to do something that's called pseudocoding. Pseudocoding, that is a technique, when you take a piece of paper and you say, what do I want the program to do? Okay, so I wanted to sort the array, or I wanted to search the array. Okay, first of all, let me draw the array. Okay, so you draw the array on a piece of paper. All right, so using binary search, what does binary search do? Splits it in half. Okay, so boom, you draw the line in half. Okay, what's that called? And how do I get that? Okay, so if I add all the elements of the array and divide them by 2, all right, so that's going to be my middle. All right, so binary involves searching the sides. Then once it splits in the middle, it searches, if it's not the middle value, right, it searches the right one, or the right side and the left side. Okay, how do I say that? How do I physically define that? How do I define that in code? Okay, so now, since the first was at the beginning of the array and the last was, or you can call it left and right, if the search was, if the first element was in the beginning of the array, the last element was in the end of the array. Okay, now what do? Okay, now you split it in half. Now you set middle. Okay, so now you have to move that first element to the one after the middle element. So how do you do that? You say first element now equals middle plus 1. So whatever the middle of the array is, it knows that it's in half. Now the first element is going to be the one after the middle. And then you search there. If it's, less or greater, then it moves. If it's, if it found it exactly there, it just displays it. If it's not on the right, then you go to the left. Now if you go to the left, how do you do this? Okay, you say, now the last element, it goes from right to left now. So you have to define the last element. What is the last element? Middle minus 1. So you go that way, right? You go that way. You go to the left, okay? So now the last element is middle minus 1. Now you say if the first is, where's that method? Let's open up the binary search, right? Binary search. Now you say, if the okay, so you say, if the integers in the middle is greater than the key, then you go to the left, right? So else if the integer in the middle is it, then okay, it found it. right? And that's it. So pretty much that's what it is, guys. Thank you guys for watching, and thank you for sticking around with me. Sorry for being kind of slow, and I have to be careful with making sure that everything is tapped correctly. So that's why I checked the program that was already done. In here, I did it already on the other computer, so I brought it here as a text file. And yeah, so hopefully that helps. And I'll see you guys later. Don't forget to subscribe, check out my other videos, and peace.